Hello, good evening, everyone, good evening. So, welcome to this session, the quantitative ability session of EduShastra. So, hello, Gurang, good evening, hello, good evening, everyone, good evening. Hello, Aparna, good evening, hello, Akshit, Subhanshu, hello, good evening, hello, Aman, hi, good evening. So, Adarsh, basically, as you are asking that this is your first class, right? And you want to know that what is the difference between these all sessions and the paid session. So basically, these we are having a basic sessions for all the topics, right? And the advanced version of these sessions will be there. So advanced version will always be there, and to get the details, to get the timings, to get the days, the schedule, what you can do, you can just send a mail at what support@edushastra.com. So to write the weekly test, to get the study material, right, the books, the student test portal. So for everything, you can write a mail at support@edushastra.com, and the head office team will share the details of all these things with you, right? So all those who are like targeting for the advanced version of the course, right? Samar, no, this is not a demo class. This is a normal regular class, right? But yes, the topic is there. That is the factors and multiple, which is one part of the numbers, and we are having a say, discussion for this. But yes, the high level of question from say CAT or Z or for some other examination, the GMAT, the CUET, right? So these will be there in the advanced session, right? So Aparna, the test for upgrading yourself for a say higher series of batches will be depend on you. Anytime you can write those tests, right? There is a no timeline. This is independent and individual to a individual person, right? So there is a no timeline that okay, this is the first week, this is the second week, right? So any individual person, when you are writing the test, depending on your scores, which you get in the test papers, right? You will be upgraded to the higher series batch, right? Okay. So now let's begin with this part that is the factors and multiples. So, okay, Lakshita. So, Lakshita, these are the say series 6, 7, 8, 9, 10, right? And these series are having a different labels of difficulty as per the examination or as per the preparation. So 6 is the most basic part, and 10 is the most high level part, right? So this is a combination, Rajni's, of 6 and 7, right? This is a combination of 6 and 7. Okay, so, okay, Sasha, I want to talk to the team for the Shastra program preparation. Okay, class. Okay, Sasha. So basically, this is for you one class, right? But now this is a regular class, and for all these details, you can take up numbers from the edushastra.com, the website, or you can take up an email address and then write, and then you will get a detailed information. Lakshita, classes, I suppose you mean to say the schedule, the days and time. No, this will depend on your first choice, first preference, right? Depending on your maybe say office timing, maybe say some college assignments, right? So all those things are this. So you can just pick up your comfortable days and your comfortable timings. Right? So, Darshan, If you are done with the normal classes, then start writing the topic test, module test, and the full length test. And then, depending on the scores of all these tests, you will be upgraded to the higher series batches, right? So that will be the advanced version of all the topics, whatever are there in the quantitative, in the logical DI, as well as in the verbal part, right? Okay. So now let's begin with this part, that is the factors and multiple. Yes, Bhavesh, you will be upgraded to the elite batches, right? But the requirement is this, some basic requirement is this, and this is basically writing the different test and scoring some minimum percentage in the test paper, right? So for this, you can just send a mail to the head office, and they will just share all the details with you. Yes, Anupma, it's yes, yes. So this is the beginning, right? Okay. So factors and multiple. Now this is a one part of the numbers, and in all the examination, you will be able to find questions based on factors and multiple. Apart from this, this will have a say application in a time and distance and time and work, algebra, right? Take a simple example that when we are talking about a quadratic equation and we are asking the what are the roots, what are the solution of any quadratic equation. So what we say, factorize the middle term, factorize the equation, right? So factors and multiples are the various application, and we will be understanding and we'll be like looking here and studying all these parts one by one, both the factors, the multiples, right? So let's begin with the first part. What are the factors and multiples, right? So if I say the elementary level of discussion here, right? So factors are the factors and multiples. Yes, these are the two key concepts for the number system, right? And which are having a same application. These are considered to be as a sisters, right? Normally, the siblings kind of thing, right? And factors are the numbers which can which divide the given number exactly, right? I'll give you some examples also for this. So factors are the numbers which will be dividing the given number exactly, whereas multiples are the number which are like what? Divided by the given numbers, right? The reverse thing is there. So getting into the details of the factors and multiples, right? Now, first understand this part, that is what are the factors. This is when a number is said to be a factor of any other second number, right? The first number must what? Divide the second one and without leaving any remainder. So there should not be any remainder. Then only I am saying that this number is a factor of the other number. So in the simple language, what I say, we know that is a dividend, right? Remember? So we have this expression dividend. Dividend is equal to what? Divisor into quotient plus remainder. Right. So when we're talking about the factors, so this part remainder should come as what? Zero. Okay. Then dividend, the number which is being divided. Right. So this is exactly divisible by the other number which is called as divisor, right? So then I am saying that divisor will be a factor of the dividend, right? Now, take an example. Suppose I say there is a number 4. So 4 is a factor of 24 because 4 is perfectly dividing 24, right? And if I go otherwise, so I can say 6 is again a one factor of the 24, which is dividing 24 again, right? So I have some factors for the 24, which is 1, 24, 4, and 6. Right. Apart from all these factors, there are some more possible factors for 24, and these are what? These are 2, 3, 8, and 12. Right. So all these numbers are called as a factors of 24, and when you're dividing 24 by any of these numbers, you will not get any remainder. So there will be a no remainder when we are dividing 24 by any of these numbers. Right. Now, this is a one extension. If any natural number has only two factors, which one? That is 1 and the number itself, right? Then this is called as what? This is called as a prime number. And 2 is what? The smallest prime number, which is again the even prime number. Then we have the 3, which is the first odd prime number, right? Then we have the 5, 7, 11, 13, right? And I normally discuss some standard results. So if I say you are having a numbers from 1 to 10, right? How many prime numbers you have? 4 primes you have from 1 to 10. 2, 3, 5, 7, right? 4 prime numbers. If I talk about 1 to 50, right? How many prime numbers you have? 15 primes you have, right? So these are the some standard results, and I suggest that please memorize them, right? If you're taking a say 1 to 100, right? How many primes you have? You have total 25 primes in this range, right? So this is the say some standard result, and I suggest memorize it, right? Okay. Now moving further, what are the factors formula? How can I calculate any number is a factor? So there are some different formulas. First is what? Number of factors, product of factors, and sum of factors. Right. So for this, what you have to do, first of all, you have to break any number in the prime factor, right? In the prime factor form, and raise the powers of each and every prime factor, right? So, for example, uh, now say this. If I say there is a number 15, right? 15. So, how can you break this number? That is 3 into 5, right? Prime factor. Raised to power, raised to power. Done. Then, if you take 30, so how many prime numbers are there? How many prime numbers are there? So, this is what? That is 2 into 3 into 5, right? Raised power 1, raised power 1, raised power, right? If I take a one more number, that is 90, right? So how many prime numbers are there? That is 2, right? Into 3 into 5, right? And when you are raising the power, so I can say this is nothing but what? 2 raised power 1, 3 square, and 5 raised, right? So this way I am what? I am factorizing the numbers. Okay. Now, because I am just explaining you and taking us say some simple easy numbers, right? So for the 15, what are the factors? 1, 3, 5, and 15, right? How many factors we have? 4. Okay. If I take for the 30, so this is what? Yes. How many factors we have? 1, 2, 3, 5, 6, right? Done. After 6, which one? This is, yes, 7, 8, 9. No, right. Next is a 10. Next is a 15. and next is a 30. Right. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 factors. Right. Now coming to 90. So tell me 1, 2, 3, right? 4 is there. 4 is there. The factor for 90. What do you say? Yes, no. Yes, tell me quick. Is the 4 a factor for 90? Yes, this is not a factor of 90. Then after this, we have 5, then 6, right? Then 9, then 10. After 10, tell me which is the next factor for 90? Yes, after 10, which is the next factor for 90? Yes, 15. After 15, which one? 18. Yes, Ashras, yes. 18. Then which one? Yes. Then 30, then 45, then 90. Right. How many total factors we have? 12 factors we have. Right. So I am taking a small numbers just to explain you okay, how the things work, right? And I'm just writing all these factors here so that you can have a good understanding of the logic and the concept. Right. So we are here. Yes, this one. The factor formula, right? So this is what my factor formula, and assume that the n is a one number, just like we have a say 15 or 30 or 90, and break these numbers into the prime factor, right? So x, y, z are the prime factor and put the powers. So we have done for the 15, 30 and 90. So this what that is the factor formula. So once you're done with this much part, right, what is the next step? Yes, this is what number of factors, right? This is for number of factors. So take an example for the 15, right? 15, what we have done? We have done 3 raised power 1 into 5 raised power 1, right? This we have done. I want to know how many total number of factors for 15, right? Remember how many factors are there? 1, 3, 5 and 15. There are 4 factors for the 15, right? Now we have this formula that is a plus 1, b plus 1, c plus 1 and so on. And what is ABC? What is ABC? That is the powers of the prime factor, right? What is ABC? Powers of the prime factor. So in this, A is what? The power of the first prime factor, that is 3. So put this as 1 plus 1, right? What is B? The power of the second prime factor. So this is what? This is 1 plus 1. And how much is this? 4. And we have already counted the factor as 1, 3, 5 and 50. Right? How many? Total 4 factors for the 50. Right? Take example for the say some other number, 90. Right? 90, what we have done? 2 raised power into 3 square into 5 raised power 1. Right? This. Now, how many factors we have counted? 12. Right? Now, in this, we have how many? Total 3 prime factors, 2, 3, and 5. Right? And every prime factor is having a sum power. So, put the formula. Now, how will you put the formula? A is what? The power of the first prime factor. That is 2. And what is the power of 2? 1. So, this is what? 1 plus, right? Second, B. What is B? The power of the second prime factor, that is 3. And this is what? 2. So this is 2 plus 1, right? What is C? Power of the third prime factor, right? So this is what? 1 plus 1. And when you simplify, so this is 2 into 3, 6, 6 into 2, 12. Right? How many factors we have for 90? 12. Right? Remember, I'll just show you here the file button. Yes, see this. So for 90, we have how many? 12 factors. Right? So this is the way we are taking and calculating the factors for any number, right? And what to do? First, break the number into the prime factor, put the powers of the all prime factors, and then apply this formula, that is a plus 1, b plus 1, c plus 1. And what are the ABC? ABC are the powers of the prime factors, right? Done? Got this? In this, say for 90, we have total how many? 12 factors, right? We have how many? 12 factors. So, if I ask you, tell me how many factors are even and how many factors are odd, right? So, just see how many are the even and how many are odd. So, 1, this is odd, 2, right? This is 3, this is 4, this is 5, right? And this is 6. So, how many are the odd factors for 90? 6 are the odd factors, right? So, suppose if I ask you, there is a number 90 and tell me how many are the total number of factors, right? So, you have done and you have broken down this into the prime factor, putting all the powers, and then applying this formula, that is e plus 1, b plus 1, c plus 1, and so on. And you're telling me that the for 90, the total number of factors are 12. I agree, right, with this, that total factors are 12. Now, my next question is what? Out of the 12 factors, tell me how many are the odd factors, right? How many are the odd factors? So, what I do, I will use the same formula, right? I will use the same formula. There is a no change, right? I will use the same formula. No change, nothing. But one thing I have to take care. And what is this? See, I am asking for the odd number of factors, right? And for 90, we have factor as 2, 3, and 5, right? Prime factor. So 2 is the one number which is an even number, right? And if I multiply 2 with any other number, right, number will become even, right? So what I do here, I just skip this factor, that is 2. I will not consider this, right? And apply the same formula, everything same with the other prime factor, that is 3 and 5. So if I take the a plus 1, b plus 1, c plus 1, and so on, right? So now 2 is not there in my consideration. I will only consider 3 and 5. And because I am considering 3 and 5, these are the two odd numbers. So can I say whatever the numbers I am making with 3 and 5 with a different combination, all those numbers will be odd, right? All those numbers will be odd. So first, a plus 1. What is a? Power of the prime factor. So what is the power of 3? So this is 2 plus 1, right? Now, second, b plus 1. What is the power of second prime factor? 5. That is 1 plus 1, right? So 2 plus 1, 3. 1 plus 1, 2. And this is what? 6. So how many are? 6 odd factors, right? There are 6 odd factors. So there is a no change, no formula, nothing. Right? Just one change, one thing I have to consider, that I will not consider 2 as a one factor, because if you consider 2, you will always get a some even number. So I just skip this and then getting a simply odd number of factors. So for 90 out of a 12 factors, there are total 6 odd factors. Yes or nothing? You have to consider only the powers of the odd prime factor, right? Because if you consider any power of 2, right, this means you are multiplying 2, and if you multiply 2, number will become even, right? So I totally disregard the number 2 and then taking consideration of all the other factors and then getting the odd number of factors, right? Now, how to find the even number of factors? So when you are, yes, Siddharth, yes, yes. So when you are having a even factors, right? So the easy way is what? When you're calculating an even number of factors. So how many are the total? Well, you have already calculated the odd factors. How much? 6. So 12 minus 6, what are the remaining part? That is an even number of factors, right? Then no, Gurang. If you are saying that if this is asking for the even number of factor and you are saying that eliminating say 3 or 5, right? So this means you are not considering the 6, right? Because say you have a this factor 6, 10, 18, 30, 90, right? So if you are not considering 3 and 5, so you will not be able to get a 10 as a factor, you will not be able to get a 18 as a factor, right, Guran? So when you are calculating the even number of factors, you have to consider all the factors, all the prime numbers, right? Done? Getting this? Okay. Now, so this is what total number of factor, even number of factors, odd number, right? Now, so coming back here, yes. So this is what my number of factors. Then now, next is what the sum of factors. So take a simple number, right? First understand the logic, the concept, and then apply to the bigger number, right? So if I say 50, right? Taking a same example, 15. 15 is what? 3 raised power 1, 5 raised, right? And you have the factor 1, 3, 5, and 50. And what we are doing here now, we are calculating sum of the factor, right? So tell me 1 plus 3 plus 5 plus 15. How much is this total? How much is this total? 24. Yes, absolutely. Right? This is 24. So for all the factors, right? For all the factors of 15, what is the total summation? What is the total addition? That is 24. Right? Now I am putting up this formula which is there on your screen, right? So now in this, remember what is x, y, and z? Yes, what are the x, y, and z? The prime factors. And what are the ABC? The powers of the prime factor, right? So now calculate. So start with this. You have the two prime factor, 3 and 5, right? So this is what? 3. Then and this is 1 plus 1. A is what? 1 minus 1, right? This x raised to power a plus 1 minus 1, right? Divided by what? This is 3 minus 1, right? This is your first term, okay? Take the second term. Now the second prime factor is what? 5. So this is 5 raised to power what? 1 plus 1, right? This is minus 1 divided by what? This is 5 minus. So everyone quickly simplify this and tell me what is the value, what is the result you are getting here. Yes, quickly. Okay, Unnati, okay, Shania, okay, okay. Others, I'm just waiting for your responses, just your answers. Yes, tell me. Okay, this is what? 24. Right, right. So this is the way I can calculate the sum of the factors, right? Sum of the factor for any number. But first thing, what you have to do, you have to break the number into the prime factor, right? And put the powers of the prime factor. If you are not doing this, you will not be able to get the number of factor or sum of factor, right? So this is the formula for sum of factor, right? Sum, yes, Partha, yes, right. Okay, good, great. So you are participating, and that's very good. If you solve right yourself, then you will be able to understand much better, right? Okay. Now moving forward. So next thing is what? Product of factors. So if I have say some factors, if I multiply, then what is the result, right? So take one example. I have the number 15, right? And for the 15, I have what? That is 1, 3, 5, and 50, right? And what we are doing now? Product multiplication. So just multiply 1 into 3 into 5 into 50 and tell me how much is the product for these all four factors of 15. Yes. What is the factor? Yes, yes, yes. This is what? 225. Right? I suppose you're getting this number. Now, how to find the product of factors? So this is what? N. What is N? The number itself, right? So this is what? 15, right? And this is total number of factors. So 15, what is the total number of factors? 4. 4 divided by 2. So this is nothing but what? 15 square. And can you tell me how much is the 15 square? How much is the 15 square? Yes, yes, absolutely, Gurang, Saraswati, yes, Anupa, yes. This is 225, right? So we are getting the same value here as what the product of the factors. So this is what my formula, my expression for product of factors, right? So this way we have what? Total number of factors, even number of factors, odd number of factors, right? Sum of factors, product of factors, right? I suppose you're getting all these different type of calculations, different type of expressions, formulae. Yes. Okay, Yatharth is saying without formula we can also find the sum of factors. Yes, 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 Yatharth. So basically, see, there are various ways, right? There are various ways of finding. Not only for the sum of factor, we can also find the product of factor. We can find the even factor, odd factor, right? There are multiple ways. But here, what we are doing, we are first trying to understand the basic concept, right? How can I identify, right? First, if I know the basic concept, the basic fundamental, then only I can go for the higher level of the calculation, right? So, Guram, we will be discussing this, right? Some of factors without the formula, but all these parts will be discussed in the say next level of sessions, right? Higher level of session. Okay, so done with this. Now, the next part. What are the multiples? So this is what the factors, right? Coming to the multiple. So if you talk about the multiple, so multiples are the what? Multiples of a number is a number that is the product of a given number and the some other natural number. Right? So for example, I say the multiples of 2, right? Multiples of 2. So multiples of 2 are what? 2, 4, 6, 8, 10, 12, 16, 20, 40, 100, 200, 1,000, 10,000, infinite number of multiples, right? And how can I identify them? If the number is having a last digit as what? 0, 2, 4, 6 or 8, then I can say the number will be a multiple of 2. Right? Similarly, if you are asking for the multiple of 3, so we have a 3, 6, 9, 12, 15, 18, 21, 27, and so on. Right? So how are we defining the multiples? Multiples are the numbers which are perfectly, right? Which are what? Which are perfectly a multiple of number which is getting a by multiplication of other number, right? So if I say 3, so 3 is what? 3 into 1. 6. 6 is what? 3 into 2. 9 is what? 3 into 3. Right? So what we are doing is multiplying the given number with some other natural number. Right? So if you multiply with 1, you're getting 3, with 2, getting a 6, with 3, getting a 9, with 4, getting a 12, with 5, getting a 15, and so on. Right. So similarly for the 5, so we have a 5, 10, 15, 20, 25, 30, 35, and so on. So all these are of the multiples of that. Right. Okay. So this is in a general definition. If x and y are the two numbers, right? And and if x divides y, right? If x divides y, so I say x is a factor of y, right? Because x is dividing y, so x is a factor of y. And otherwise, if I say if y is divisible by x, then what? Y is a multiple of x. So simple. If I say there are two numbers, say x is 3 and y is 9. Right. So now x, which is 3, dividing y. So 3 is what? The factor of y. Right. And if y is divisible by x, so 9 is divisible by x, right? 3. So y is what? A multiple of x, that is 9 is a multiple of 3. Right. So this way we are having a factors and multiples. And as I discussed in the beginning, that factors and multiples normally we are saying that the siblings, the sisters, right? Now, if I say since the number one is number one divides every other number, right? So this is what a common factor of every integer, every integer, right? And every number is divisible by one, right? And this means what? And every number is a multiple of one, right? So one is the factor of every number, and every number is a multiple of one, right? Yes, got it. Now, just see the difference between the factors and multiples. First point, factors are defined as the exact divisors of the given number, right? So this is the first point. And multiples are defined as the numbers obtained when multiplied by other natural number, right? So factors are dividing the numbers, right? And multiples are divided by number, right? Second point, the numbers, the number of factor is finite, right? As we have seen for 15 is 4, for 30 is 8, for 90 is 12. So I can calculate, okay, this much is the number of factors. But the multiples are infinite. You can go till infinite and you will be finding the multiple, right? Third point, the operation used to find the factor is the division, right? Because you're breaking down the number into the smaller part, right? So you're using division. And for the multiples, this is what? Multiplication. As I have shown you, the 3 into 1, 3 into 2, 3 into 3, 3 into 4, and so on, right? And the last point, the last difference is what? The outcome of the factor should be less than or equal to the given number, right? So for 15, take example. For 15, we have 1, 3, 5, and 15, right? What should be less than or equal to the given number, right? And for the multiple, the outcome of the multiple should be greater than or equal to the given number. So, for example, 3, right? This is 3 equal to the given number, right? Then 6, 9, 12, 15, and so on. So, this is what? Equal or greater than. Multiples are equal or greater than, and factors are what? Equal or less than, right? Okay. Now, okay. So, just tell me this. Everyone, I suggest to solve, to simplify this and give me a sum value. Give me a sum. So, Gurang, this finding this part, that is a sum of factor without the formula, will be say the next level of concept, and this we discuss in the high level of classes, the advanced version of all these topics, right? Okay. So tell me, how many three-digit number have exactly three positive factors? Yes, tell me. How many, how many three-digit numbers have exactly three positive factors? Yes. So I suggest to everyone just solve, just revise. Okay, Saraswati. Okay, okay. Okay, so Gurang, Partha. Okay, okay, right. So Saraswati, as you're saying the answer 22, right? So this is not there in the option. Do you want to say the option C, 2? Okay, 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 Samar, okay. So first, I am just coming with hello, Partha, T and Partha. Just unmute yourself.
Yes, sir.
So how is your answer? The none?
So, uh, if any number, any three-digit number, have more than, let's say it's a prime number, then it will only have two factors. And
Okay,
it's not a prime number, then so it will be divided by two.
okay.
Let's say it will
Mm-hmm.
then the half of the number will also be the factor. And if say it will be divided by 3, then
Mm-hmm.
one third of the number will also be the factor of. That's why.
Okay, so this means you're saying that answer will be first option A,
No.
none.
Yes, sir.
No, Yatharth, no, there is a no formula to find the number of three-digit numbers, right? But you can just apply the concept of permutation and combination here to identify the numbers, right? Okay, and okay, okay, so okay, now hello, Samar.
Yes, sir.
So, Samar, how is the answer four, the fourth option for you?
Sorry, it was wrong. So I want to change my answer with none also. I
Okay,
think
so
none
how
is
is
right.
this none? Okay, how is this none?
So because as the previous one stated that no 3-digit number has exactly 3 positive factors, because like if we take 333,
Mm-hmm. Mm-hmm.
so only 3 and 1, only 333 and 1 will be the correct positive factors. And as such, I have take 555, 999, 777
Mm-hmm.
also, like
Mm-hmm.
four sentences, but they all result in same. So I guess it's none.
So, Partha, Samar, tell me one thing. Why are you taking all the digits similar, like 333, 555? You can take us a some number, will be like, say, 1, 2, and 3. Yes or no? Right? Okay. So, okay, hello, Neha. Just unmute yourself.
Hi, yes, sir. Good evening, sir.
Good evening. Good evening. So, Neha, how is your answer? First, tell your answer. What is your answer?
So, option E, 7.
Okay, and how is this?
So actually, I just took like this squaring. If we take 11 ka square, it's 121.
Mm-hmm.
So it's 111 and 121 three factor. Similarly,
Mm-hmm.
13 square, then 14, 15 we cannot take. 16 also we cannot take. Then
Mm-hmm.
17 square, 19, 23, 29, and after that 961 is 31 square. After that, if we take
Okay.
square which has only three factor, that comes to be 4, like 4 digits. So
Mm-hmm.
that way.
Okay. So, see, Yatharth, as you're asking to like have some formula. So, normally in the numbers, we have a very limited formula, and we have to typically count the numbers, right? Depending on the condition, because the condition is given here. So, now I am starting with a say very simple example. First, taking a say one digit and two, so that you can understand. Suppose if I have a number 9, right? Number 9. What are the factors? 1, 3, and 9. Okay, simple, very easy, simple, easy number. If I say you have the number 25, right? How many factors are there? 1, 5, and 25, right? First, understand this. This is saying exactly 3 positive factors, right? First, understand this phrase, this statement. Exactly 3 positive factors, and I am taking all the examples which have exactly 3 factors, right? Now, if I say you have the number 49, done. So, what is there? 1, 7, and 49, right? I suppose you're getting a some point, right? Catching a some clue here. Yes or no? Getting some clue, some point here. So tell me what? Yes, yes. Yatharth, no, not this, not this, not this. See, Yatharth, I am taking a yes, Shriram. Mahima, no, not exactly. See, if you're talking about the squares, so see, here I am not taking a square of, say, for example, 16, right? Say, for example, 36. I am not taking this. Yes, Lakshita. Yes, yes, yes. See, I am not taking this one, not this one. I am taking 9, 25, 7, right? Why? Uh, but Yatharth, how do you know that these have only three factor? Right. See, all these perfect squares which I am taking here, right? They are They are what? Yes, they are what? They are having, yes, quickly tell me what? They are the perfect square of the prime numbers. They are the perfect square of all the prime numbers, right? So you are starting for what? Three digit number, right? So 3-digit number, the range you have to consider is what? 100 to what? 999. Right? This is your range, 3-digit number. In this range, you have to check, right, what? The perfect square of the prime numbers, right? So in this range, can I say the first number which should be considered here is what? 11 square, 121, right? 11, then 13, then 17, then 19, right? The perfect square of all the prime factors will have how much? That is exactly 3 positive factors, right? Now 19. After 19, tell me the next number. Tell me the next number. After 19. Yes, 23. Next. Quickly, quickly. Yes, 23. Yes, 29. Next, 31. Right? Because 11 square is what? 121. And 31 square is what? That is 961. Right? If you are taking a next number, suppose if you take a 32, right? So just from the next number, how much is 32 square? How much is 30? Yes, yes, Saso. 1024, right? So after this, you take any prime factor, right? Your answer, your perfect square will be in a how much? 4-digit, right? So you want what? That is exactly a 3-digit perfect square, right? How many 3-digit numbers are there? None, which have exactly 3 positive factors, right? So how many numbers I have? 1, 2, 3, 4, 5, 6, 7. My answer is what? That is a E option, right? That is 7. No, no, Yatharth, no, we cannot find this through the permutation and combination, right? Getting this? Yes. So see, this is the kind of question you will be getting in the examination, and they're typically calculation based, right? And Yatharth, if you're talking about the permutation combination, right? So even from the permutation combination, we are not getting questions based on the formula, right? Go back to the schooling days. Remember when you have studied this permutation combination. So the chapter name in the standard NCRT book, this was that is a what fundamental principle of counting, and we have a two principle. One is the additive rule, and one is a multiplicative. Right, Yatharth? So now the questions are based on the fundamental principle of counting rather than on the formula. Right? Okay. So Rajneesh is saying 3 positive factor is one number itself and the yes. So Rajneesh here the 3 positive factors are what? One number itself, right? And the number when you're taking the square root of the number, right? So 121 square root is 11, right? 13, 169 square root is 13, and so on, right? So, Saswat, so when you have written down the perfect square, the question is done, right? So, what you're doing, you have to ask for the 3 positive factor. So, 11, what are the factors? 1, 11, and 121. 13, what are the factors? 1, 13, and 169. So, these are the factors, and this way you are getting your answers, right? So, answer is what? The option is 7, right? Okay. So, come to this quickly. Yes, a smallest number which will have the 18 factors. Yes, a smallest number which will have the 18 factors. Gurang, if I take a 12 and 16, right? So 12 and 16 will have a more than three factors, right? So this is the reason I am not considering the 12 and 16 is square, right? Okay, Gurang, okay, okay. Yes, Siddharth, yes, yes. So see, I have the four options, right? And this is exactly three factors. So what to do here? I can just check the factor. So if you're taking a first number as 180, right? So break this. So you can say this is 18 into 10, right? And 18 is what? 2 into 9, and 10 is 2 into 5. So I can say when I'm breaking this into the prime factor, so 2 is square, right? Into 3 is square into 5 raised to power 1, right? These are the prime factors. Now check the total number of factors. So this is what? 2 plus 1, right? And this is 2 plus 1, and this is 1 plus 1, right? So this is 3 into 3, 9, 9 into 2, 18. So this is 18 are the number of factors, right? Okay, so Sandeep is saying 288, Prachi is saying 288, right? But Sandeep and Prachi, the question is what? Find a smallest number, right? Sandeep and Prachi. So 288 you may get, right? You may get the 18 as a factor, but you have to find the smallest number, right? So smallest number out of the given option is what? My option A, that is 180, right? Yes, Gurang, yes, Lakshita, yes, yes, absolutely correct. So this is 180, right? Getting this? So this is the kind of questions you are getting based on a factors and multiple, right? And this is a one part where you are having a say application in the time and distance, time and work, in algebra also when you're breaking down the equation. So what I do, I'm just sharing this file here, and Neha, see, we are having all these numbers, right? So if out of these numbers we are not having, right, then I am saying this is what my other number, right? So, so then Lakshita, if yeah, so this is the one question Lakshita is saying. If we are not having any factor, right? If we are not having any option, then how to calculate, right? So, see, we are having this formula. I'll just give you a clue, right? And detailed will be discussed in the advanced version of session. So, suppose if I say there is a some time factor x, right? And when you're breaking down this number, any number, suppose if you're having a number n and you're breaking down this number n, right, into the some time factor, and you're getting a x raised to power say 17. So how many factors you have, Lakshita? 18 factors, right? So number should be of this form. Okay. Now suppose you have a number say x into y, right? Now there are some various different things. So one clue I am saying that suppose you are having a what you can say x raised to power 1 and y raised to power 8. Right? So 1 plus 1 2 and 8 plus 1 9. So 9 into 2 18. Right? So this way you have to identify and then you have to break down all the possibilities and then you can get the total number or the smallest number, right? But yes, don't worry, we will be discussing this in the advanced version of classes.